Now that we're heading into the part where you'll be doing some quote-unquote programming, we need to take a look at Atom. So make sure before you work through this particular video that you've of course already installed things. There's a video for installing Atom itself, as well as several other programs that we'll be using throughout the semester. And then there's a video for installing packages for Atom, which you'll also want to make sure you've done. Now, if you've just installed Atom and haven't really done anything with it yet, when you first fire it up, you'll be looking at something like this. This is the welcome guide. Over at the left is just a simple little welcome screen that gives you some other places you can go. And at the right are some common places you might like to go in order to install packages, open a project, things like that. You might want to play around with these a little bit. For our purposes, though, we're just going to dismiss this. First of all, you probably don't want to see this every time it starts up, so uncheck this box. Then you can close these off. If you close all the way down to nothing, you'll be staring at a blank screen, and it will give you some little tips about ways that you can use Atom. Atom is going to organize your work by directory or folder. Every time you're working on a project, generally speaking, you'll have one folder in which all of the files are saved. You might want to do this per homework. You might want to do it per unit. You can really organize it any way you want. But this is always where you need to start. Initially here, let's go ahead and open up a particular folder. If you're on Mac, you would just go to Open. If you're on Windows, you'll have Open and Open Folder. Go ahead and do the Open Folder. I'm going to go ahead and create a place where I can keep all of this information. I'll just do it on my desktop for now. Make certain you set this somewhere reasonable where you can get back to it. Maybe it's on your D drive, maybe it's in your documents, and you probably want to create a new folder just for this class. Underneath that, you might also want to create folders for units, for a particular homework assignment, for in-class work, things like that. I'm going to go ahead and put on here worked examples. And anything that we work in our work together will go under that particular folder. And then we open that. You still won't see anything in particular yet, other than now you have a project tree that's visible over here. This can be shrunk and expanded using that little arrow icon that hides itself right there. And under here, if we had any files, those files would be shown. So at this point, we have a place to place the files. Let's go ahead and make a file. You can, of course, do this from File, New File if you want. You can also just do Control-N, I believe. Or, my personal favorite, right-click on the folder itself and say New File. This gives you an opportunity to name it right here. When you name the file, the extension is important. The extension is the part that comes after the period. So in this case, let's call this example 1.html. I prefer to put the full .html as the extension, though you'll see there are very commonly files that do just .htm. This is because older versions of DOS could only support 3 characters as an extension. There's really no need for it now, so I prefer to do .html. Now we have ourselves a blank file that is ready to be edited and worked with. Let's take a look around here just a little bit so that we see everything that Atom is telling us. First and foremost, there's some important information down on the right. Right here, it'll tell you what language it thinks you're in, and it's correctly guessed that we are in HTML. Also, it tells you the particular encoding of the text. Now, this is a fairly complex idea. Note that not every language uses the same basic 26 letters that we do, and consequently, it goes beyond what you can normally encode in a text file. And therefore, they use special sequences in order to encode that better, the most common of which is usually called Unicode. Unicode can be encoded inside of a text file many different ways. The most common one, and the one it will default to, is UTF-8. And this is probably what you want to stick with. The next thing that's on here is what type of line ending it's going to use. This is a text file, and text files have never agreed exactly on how they indicate that a line has ended. So, if you're working in Windows, the general way to do it is with 2 characters, a carriage return and a line feed, or CRLF. If you are on a Unix-like system, like I am, I'm on OS X, the standard is to use just a single line feed character. There are other standards as well. You can sometimes use a single carriage return character, though that is largely out of practice anymore. There are even other strange combinations. Normally, it will pick the one most appropriate for your system. So if you're on Windows, you're probably seeing CRLF down here. If you're on a Unix-like system, you're seeing LF. It really doesn't matter what you do. Just note that you can click on it and change it really easily between those two most popular ones. Don't use any others. Use either CRLF or LF. The other thing you should note is that Atom always tries to sense this automatically, and occasionally down here it will say mixed, which means it thinks it's seeing both kinds. If you ever see that, it's really important that you click it and change it to be one or the other, either LF or CRLF. It will silently fix them all for you. Mixed is always a bad idea. If you use it correctly, you should never wind up in any of those situations. You also don't have to worry about when you're submitting it to me what sort of line ending it is in, because as long as you're consistent, the editor can always figure it out. So here we are, staring at our file. It's usually a good idea to make sure you've already done the reading before you go through these videos, and for this one, that is definitely the case. We're going to dive right in and try and create an HTML file here. So, we always want to start with our doc type as HTML. And you'll notice that it keeps talking about other basic things as you're typing here. In fact, whenever you do the doc type, it actually offers to you to drop that in for you. If we hit that, it puts in basically what I just put in, only it's capitalized, which is probably what it should be. And so it's going to help you kind of finish things as you're going along. Now the first thing we need to do once we've set doc type HTML is we need to put in an actual HTML setup. And I always recommend putting in lang equals en on that, which tells it we're in English. Were you ever not in English? You could put that right there. You usually then need two things. We need a head, and we need a body. So you'll notice as I'm going along here, it's giving me all kinds of suggestions. It's usually a good idea to pay attention to some of those as you're typing and making sure that they all make sense, and sort of learning what it is it's trying to suggest to you. What it's suggesting to you are all the basics that you should already know from reading the text, so you don't necessarily need to constantly pay attention to them. Now, it's telling us that something's wrong here. You are probably not seeing that yet, because your particular package isn't necessarily set up to debug your code. Debugging is really just the process of checking for errors as you go. It really doesn't even have to be as you go. Any sort of debugging step is meant to just go through and check your code for errors. In Atom, we really don't have a full debugger at our disposal. Instead, we have something called a linter. A linter the name actually refers to a very old tool that came back from the Bell Labs days in the 1970s, where you literally ran the command lint from the command line in order to check for errors in your code. And it was a real simple error checker. That command still exists today. You can run lint to check for code in certain languages. And here, anytime you have a real simple checker that can go through and examine your code and decide whether it's correct or not, it's called a linter. Atom makes use of linters in order to quickly check your code in the background as you're typing. This is very different from something like Eclipse or Visual Studio, where they're actually running your code and parsing it fully to check for errors. This means it will run quicker, but it also means that it will not catch all errors. With HTML, you can rest assured it will pretty much find anything that could possibly be wrong, because HTML isn't really a programming language. It's just a sort of way of marking up content, literally a markup language, just like the name suggests. Let's see about how we can get this fixed so that you guys can get the same benefit. You have the proper package installed, however, it is not yet configured. Let's go up, and you're going to want to open up your preferences. If you're on Windows, it'll be under File Settings. If you're on a Mac, it'll be under Atom Preferences. Over here, as you should have seen when you were installing things, there's lots of different things you can play around with if you want to. Right now, we just want to go over into Packages, and we're going to want to take a look at the installed packages. Now, let's get right to the one we want. It is the VNU linter. And so you should have installed this when you installed the packages in Atom itself. If you haven't, go install it now, linter-vnu. You can pause the video while you're doing that. Let's go under Settings. And really, there's only one setting we need to worry about. And basically, we need to tell it Where should I go in order to find the server that's going to tell me, it's going to do the checking for me? This is called the NU server. It is the validator. v.nu is the name of the program, and there's lots of different ones you can use out there. However, they don't want you using a public one for checking on the fly, i.e. in the background constantly while you're using it. And we don't have to. We've set up our own here at Stout. Here is exactly what you need to type in. It's https://SE projects, that stands for Software Engineering Projects, .mscs.uwstout.edu. Then you need /VNU at the end. Once you put that in there, it will know where to find the server. Now, one big caution. This will not work unless you're either on campus or connected to the Virtual Private Network, VPN, for Stout. I will post a link that shows you how to set up the virtual private networking if you'd like to, just so you can take advantage of that, because I imagine most of you will not be working from campus. So keep that in mind. If you don't have it set up, it won't really cause problems, but it will say that the server is not reachable, and it won't be able to check your HTML code for you. So make sure that you do connect to the VPN so that you get that advantage. There'll be many other things that we're doing in the class that will require that as well. With that in place, you should now be getting this error. The other thing you can do is you can get more info on that error. Down here is the status of the current linter. It shows you if there's any errors, warnings, or information that comes out of it. We have 2 errors, so let's click that. This is going to expand the little linter box. We can pull this up a little bit and tell you that there were errors, and here's what the error is. Head is missing. A required instance of child element title. Get used to reading these errors as well and understanding them. So it says, within our head, we are required to have a title. And this is absolutely true. So let's add one. This is important. I will check that for you. Now it's telling me title must not be empty, so it's way ahead of me. I'm of course going to fill it in here in a moment, but it doesn't know that. I'll say this is my example page. And now it's happy. You'll notice it still provides one final thing that says the document validates according to the specified schema. So it does finally tell you that everything's correct. Remember, if you want to get rid of this, you can just click the down arrow and it goes away again. And you can always check over here to see what the status is. Plus, look at your file itself. It will tell you whenever there's errors. So what did we use here? Let's take a look at all these tags and make sure you understand them. The first is the doc type tag. This is a fairly recent tag that is used inside of every XML file in order to tell it what kind of XML it is. Now remember, XML is kind of a different language than HTML, one that was actually made after HTML in order to take all the value of HTML and make it more generic, so that you can use that type of style to represent any sort of document structure. XML can be used to represent a lot of different things. These days it's usually used to represent arbitrary data. You have a table of data, you can put it all together in an XML file. And in fact, XML really has become somewhat antiquated and isn't used much anymore. XHTML is definitely antiquated, though you will see it all over the place on the web. You should not be writing pages in XHTML anymore. Instead, we write them in what's called HTML5. And HTML5 always starts with this tag exactly as it's written here. Just always put it there. Next up, we have the actual HTML tag. This must surround everything in your page. There should be nothing except for the doc type tag outside of the HTML tag. Also, note that every tag, at least in general, has both an opening and a closing, and whatever goes in between it is a child of that tag. There are a few exceptions to that. Notably, the doc type tag never closes. It's just a single standalone tag. And we will eventually see there are some tags that close themselves, and so they both open and close in the same tag. But there's a special syntax just for that. Underneath HTML, we have 2 children. We have head and we have body. And that is usually all you have under the HTML tag. There should be one head tag and there should be one body. There should always be a head tag and a body tag. Do not forget these. There should also never be any tags that are outside of head or body. HTML should have one head tag and one body tag, and that's it. While there may be the possibility of putting other tags inside of the HTML tag, this is not standard practice. Head can contain many things in it, but usually the most important thing is the title. You'll note it's the one and only required tag that should go inside your head. Title is important because it is displayed as the name of the tab or at the near the top of the window whenever you load up that page. So it is something the user actually sees. The other thing you'll see inside of the head tag from time to time are meta tags. And there's lots of different meta tags out there. Here's an example of a self-closing tag. The meta tag would need to have some more information in it to be complete. I've gotten to where I just generally don't bother with the meta tags unless I'm making a really robust web page. And I would imagine if you study digital marketing, you're probably used to meta tags and what they can be used to do. Feel free to add them as you need. Maybe have a standard set of meta tags that you're always putting in. These are always useful. For our purposes, we're not going to bother with them because the page itself will render just fine without meta tags in there, as long as we're always viewing it in a normal desktop web browser. The other thing that we'll occasionally see inside of the head are either script tags, if we want to be able to write some JavaScript, though I recommend putting those in the body. You can put them in the head. And the last thing that we might occasionally see there are style tags. This is where we will put our CSS from time to time. Sometimes the CSS comes in from a completely different file rather than being written right inside the head. And in that case, we'll use a link tag. And a link will allow you to pull in CSS from a separate tag. Now again, we'd need an actual tag that we could pull in at that point, so we won't do anything with that yet. This is all you should ever see under the head. So what did we have? We have title, meta, style, script, and link. So make sure you know all of those. You'll learn more about things like style, script, and link much later on, but know that those are the only ones that you should really ever be showing up inside the head, and the one you're required to have every time is the title. And yes, you are required. Make sure you always put it in your homework. I'll be looking for it. Under the body is where you can put your content. This is where the stuff is that will be rendered and shown to the user inside the body. The only thing inside the head that's directly rendered and shown is the title, and that even that sometimes doesn't get shown. For the body, you have lots of different options of things that you might decide to make visible. We'll go through a whole list of these tags and start examining what we can put in there in the next video, but for now, let's go ahead and drop in something like a P. P usually stands for paragraph and is used to show things in paragraph style. Let's say this is my first paragraph. P doesn't have any tagged children, but it does have this text that is contained inside of it. So in that case, it will know to format that as if it were intended to be a single paragraph. And the layout engine in your browser will treat it as such. Let's also make, I usually like to do my tabs like this. Let's also make a header or title. For that, we use H tags, and there's a bunch. H1, 2, 3, 4, 5, and 6. Let's do H1. H1 will be the strongest, 2 less strong, 3 less strong, all the way down to 6 being the weakest of the bunch. And in here, let's go ahead and put a title. Here we have the basic beginnings of a web page. At this point, you want to make sure you've saved it, and I usually recommend getting in the habit of saving frequently using Control S or Command S if you're on a Mac. It's a good idea to do that frequently. You can also come up here, File, Save. Note that it does not save automatically. You do have to do that yourself, and you might lose information if you aren't doing it frequently. I probably don't have to tell you that, you know that. Now what do we do with this? This is an HTML file. This is typically what might be sent back as part of the body of an HTTP response. If a client said to a server, give me example1.html, the server would try and locate it. Assuming it can locate it, it will send back a header that says OK or code 200 and then sends exactly the contents of this file to the client. We're going to simulate that. In fact, we will do this really simply. Instead of trying to actually load that file, we're going to go over here to where we saved it, and we're going to just open it directly. You can double click on it, you can drag it into a browser. All we really have to do is open it up, and here's what it renders. So here you can see it says fancy header. This is my first paragraph. You'll notice here, because this is Safari, it doesn't even print the title anywhere. Let's go ahead and open a second tab When we do that, you'll notice then the title is printed in the name of the tab. This isn't true of every browser. This is just how Safari tends to behave. And Safari is my default on Mac. Let's go ahead and take a look a little bit further here just to make certain we're getting what we expect. You'll want to right-click and say Inspect. If you're in Chrome, you'll see that. If you're in Safari, you'll see that. And just click Inspect. This brings up what we would call the developer tools and gives you the opportunity to go deeper into that. Now, if your developer tools are not enabled for any reason, make sure you go and do that. They talk about how to do that in the textbook, so hopefully you've got that all enabled and ready to go. Here, you can look at a couple different things. Resources is not a bad idea. This allows us to look at the exact file we were sent, and here it is. This is exactly what we typed into the text file. It just loaded it in. There's also the elements, or the document object model, the DOM, that we can look at here. And this is going to look very similar to what was in the file, but this has actually been parsed and processed by the browser and has been organized into that parent-child structure. So notice here, HTML has two children, head and body. As I roll over them, it's in fact highlighting them up in the top there. Head has one child, title. Body has two children, H1 and P. All of this can be very useful for debugging and figuring out, make certain that you're looking at exactly the file that you think you are. This is the basics of using Atom. For the initial Unit 1, this is all we'll really have to do. We'll edit our files over here, make sure they are saved in a place where we know how to get to them, possibly separated by homework assignment or unit, and then we'll load it up in a browser. You'll notice as we go on further that there'll be quicker ways to load it into the browser and little tricks like that. We'll cover those as they become important. For now, you should have everything you need to know to actually get started with Atom.